needed a pointer to the struct. We passed the address of it to reference elements inside of that would be the arrow. So if we were referencing a pointer that was inside of that, then it would be arrow star value, because you were getting if you wanted the value at that, because now it's the struct was a pointer, you use the arrow syntax with a struct pointer, you have your value, and then if your value happens to be a pointer, then you would need another star to get the value at that pointer. So, and you probably would have needed some fancy parentheses in there too, for it to parse correctly. But yeah, so that would have made pretty cool looking syntax, but interesting, weird looking syntax for having int pointers inside of a struct that was being passed by address. But it still could have done it. Yeah. It just would have been kind of weird looking. All right. Oh, I did fix the Bible homework, but so there was I had Bible homework 8 up and then also Bible homework 9 up, right? That was the same assignment, but last week was Bible homework 8. And I deleted the 9s, and I have 2 8s and a 9. Or no, 2 8s, no 9. So if you had already turned your assignment into 9, resubmit it to the 8, the second 8. Yeah, the second the second 8. Okay, and I'll delete that one and give everybody a 0. That all makes sense. Yeah, so turn your Bible homework into Bible homework 8 this week, even though you also had one named 8 last week. They are 2 separate Dropboxes. Because actually what I can do is I'll go in and rename it to 9, but I won't delete it. So it'll show up differently anyways. But if you had previously submitted it to homework 9, resubmit it because I've deleted all your entries. Yeah. Okay, so let's go in here and get this chat server dealy flippy thing working. Big money. Okay. So I know some of these things we don't actually need. We're not going to need shared memory anymore. So go ahead and take that out. We actually won't need IPC for right now. We'll put it back in when we bring in semaphores. We do need standard lib. We do need net inet. We do need standard def. We do need. Okay. So since a socket ID is just an int, and since we're passing our client thread struct as by pointer, by address, we could actually store this as just an int. You could have still done it as an int star, it just wasn't necessary. We didn't need a pointer to that guy because we already housed it inside of a structure, which gives it, because structures are predecessors to classes, right? So these guys kind of have their own little home in memory, sort of kind of like creating a new instance of a class. It does get a portion of memory assigned to it. So you didn't have to use a pointer if you didn't want to. It would have worked. You would have had to have some interesting syntax, but it's fine. Same thing with the number of connected clients. Or rather, connected clients, this does need to be a pointer. Now, what's interesting here is I actually would have thought number of connected clients here would need to be a pointer. Socket ID would not have to be, because this guy's not changing. This is the socket ID of this particular client's connected client, right? So that's not something that's going to be modifying. But number of connected clients, this is going to be modified. This is something that will change by the server when a new client comes and he adds it to that number of connected clients. This guy will be modified. So this should be a pointer. It shouldn't have worked if it wasn't a pointer, because then you would have had your own copy of that value. And as the number of incoming connections increased, as the server added connection 5, connection 6, connection 7, the client thread that had the original would have still had number of connected clients would have been 2 still, and that would have never changed because you didn't have a pointer to the value. So this guy still needed to be a pointer. This guy could have been a flat int. Right, because we do want this variable to change as a result of changes that the server is making to those numbers, correct? All right. So let's review real quick, make sure our server is doing what it's supposed to do. So our server has our, this is going to be our collection of integers up to 100 connected clients at once. Number of connected clients initially is 0, so this is just a local variable for our server. Server does all this other crap, blah, blah, blah. Down here is when we actually finally have our new client connected. So new client is connected. So then we're going to say we'll add that socket to our connected clients, to that array. Then we'll increment number of connected clients by 1. This is a local variable, not a pointer. This is a local variable of our server. All right, then we're going to go ahead and create a instance of we'll call it an instance right now, an instance of our client thread struct. And we're going to set the socket ID equal to, now new socket was an int pointer here because that's what we had to pass in here, and I think that's why we kept it as an int pointer up there. So what we would actually have to pass in here, if we're just going to store it as an int.
You don't actually have to pass an int pointer.
Say this again?
Where we have where we're passing it into the new socket and the int there, doesn't have to be an int pointer.
Oh, you mean this guy up here, where we're creating it?
You just made an int pointer because it has an int pointer.
I get what you're saying. Yeah, so you could have made an int and then set the int there.
Right.
Yeah, I get it, because this is just getting the received value.
Yeah.
So you could either fix it here, or down here you would have just given it the star, this value, for the thing that lived there. Same thing. All right, so we have our incoming connection. Connection was, we add him to our list of sockets. So now, since we took away the star up there, this is just going to be our new socket, just an int that we're throwing into this array of integers. Then we'll update our number of connected clients. This is just a plain Jane int. Create our struct. We'll set the socket ID equal to that plain int. We'll set the connected clients, which is expecting an int pointer, equal to the connected clients here, which is an int pointer. And then the number of connected clients should be the address of that guy, because we want our client threads to recognize changes made to that integer. Correct? All right. So we're going to pass that guy by address. So even though the parent here, the server, is dealing with this as a flat integer, just making changes to it normally, he's going to let those threads know where they can find that integer in memory so they can make changes to it. Or they won't be making changes to it, but they'll be seeing changes that are made to it. Okay? Otherwise, they would never have their values updated. All right, that all makes sense? Then we're going to create our p-thread, start our thread up, and have him start doing his new thing. We are passing it, we're calling the client thread func. And we're passing it the address of the struct we just created. All right, so because we're passing the address of a struct, that's what necessitated the arrow syntax we talked about last time. And then the parent goes back and waits for another call to come in. Okay, so the parent's entire role, the server's entire role is to receive incoming connections, add them to the list, increment the number of connected clients, and then spawn off a new thread, passing it the address of that newly created struct. That's his whole job in life. Okay. Then up here in our client thread func, this guy takes in our client thread pointer. We have our welcome message here. We'll set our client thread pointer CT equal to what that thing that was passed in, because it came in as a void pointer, so this allows us to conveniently work with it. Probably maybe a bigger deal if you're working with an IDE that's doing command completion, but in any case, we'll go ahead and create our buffer for reading stuff in from this client. We'll go ahead and write out to our client. So this is we're writing out to that socket ID, to that integer, our welcome message, and then we're passing it the length of that welcome message. All right, so now this is where the client is doing all of their work. So the client's going to keep track of the number of bytes that were read in, and then forever, the client will try to read in, well, the thread will try to read in from the client. So we're going to read from the socket ID associated with the client into our buffer a maximum amount of 1,024 bytes. Then the thread's going to go ahead and print out what it read in. All right, and this guy should notice where the \0 was. So Tim was talking to me before class and mentioned that some of you had issues where if you read in a sentence, it would, and then you read in something short, when it printed it out the next time, it showed the short thing followed by the rest of the sentence. Okay, that has to do with where the \0 is getting put. So we'll investigate that when it comes up. I think he mentioned some of you used memset to clear it out. You could have cleared it out. You could have filled it up with \0s. You could have used string copy to move the string in. Or you could have just artificially inserted your \0 after the things that you read in. Okay? But the issue there is you had a \0 significantly farther down in buffer as opposed to the short thing. Because you had the big sentence with the \0 here, and then you said hi, no \0 here. So string length of that guy wasn't getting detected. Is what I presume the issue is. All right, so we'll just echo out here that that's what the client read in, and then our job is to broadcast to everyone except us. So this is really besides the other changes, this is the piece that we were to write. So we're going to go through all of our connected clients. Now, this guy, that will give me the value at number of connected clients. Now, this guy should, though, this will give me the struct's value, which is number of connected clients. The value of that guy is a memory address. So I want the value that lives at that memory address. I think that should work. If it doesn't, we might need to put it in. Actually, no, it's not that. It's this. That is the value, and this might be where we need to put the parentheses in. This says, go to the struct, give me the value for number of connected clients. Number of connected clients, this whole thing should boil down to a memory address. Then give me the value that lives at that memory address. This should give us the actual value associated with the current number of connected clients that only the server, the main thread, is manipulating. All right, so this should loop through all of the things that are in there, and then our job is to broadcast to everyone that's in there, and our broadcast message is this guy here, but we're broadcasting something different, so I'll just steal that line and then we'll doctor it. So I'm sending something. Where am I sending it? Not to CT socket ID, but instead I'm sending it to, the connected clients. Is that what it's called? Yeah, connected clients at a particular bucket. So this is going to be ct.connectedClients. Okay, so this will be the memory address of where that guy lives, right? And I want to send this to the value that lives at that memory address plus I. Okay, so this is the pointer that leads to where my connected clients live in memory. So my version of shared memory, even though we didn't actually have to use official interprocess communication shared memory here because we're sharing it amongst our threads. So this is the memory address of that, offset by which connected client are we dealing with. And the value that lives at that position is going to be the int for the socket ID. So that's who I'm sending it to. Now, what am I sending? I'm sending buffer. That's the message I'm sending. And what and how long is that? Well, for right now, we'll say string length of buffer. Okay, so I'm broadcasting that right now. I'm broadcasting that to everybody, including myself. Okay. Now, what we might want to do in here, though, is we might want to say int cur socket ID, something like that. And then maybe in here, we want to say cur socket ID is equal to, oops, sorry. That value, the socket ID of the guy we are potentially going to broadcast to. Then we're going to ask the question, if cur socket ID is not equal to CT socket ID. If it's not us, then we want to broadcast to cur socket ID. And then maybe up here, if we want to, we might say you said this instead of from client. So you said this, and then maybe down here it would be a, the message is just going to be from like this anonymous thing, right? Because we didn't have them like log in with their name. That might have been an interesting thing to do, is to originally have them read in like, what your chat name is going to be. That way, when it sent your message, it built a message that was your name followed by a colon followed by what you said. That way, you just don't have a wall of text from anonymous or something like that. But those are little things we can change. So we'll go through all the current connected clients, grab the current socket ID that we're interested in right now, determine if it's not us, that means we can broadcast to them, and then we'll go ahead and send to that socket ID our buffer with the string length of buffer. And that should broadcast to everyone, except us. But we're locally broadcasting to ourselves by just saying you said, something like that. Okay, so that looks decent. Let's see what we broke. So and this is not thread example, this is chat server, right? And we do need to run this as sudo. Actually, we don't have to compile it as sudo. We need to run it as sudo. Are you doing it on the Mac or are you doing it on Cloud 9?
I'm doing my Mac.
Yeah, I kind of remember when I first put the example up there. Well, let's try it. I think it wouldn't let us bind on Cloud 9 without sudo. Could be wrong. We'll see where it crashes. What's my port? 9012. So I'm going to telnet to localhost on 9012. So we got it connected there. Telnet localhost 9012. We'll just do two of them. So this is the thread putting out connected. This guy should have said created new client connected, so it's received 2 incoming connections. So we'll have this guy, probably should have kicked that down a line, but we didn't. So I'll say hello. Didn't say you said hello. I would have expected that. So that's me reading in the hello. This isn't our client. So we printed out connected. We could probably go ahead and put the \n there to kick it down a line. Then we're sending that message there. Then we're reading in this message. Let's go ahead and print out. See, I'm guessing we're not getting past this line. This read is blocking.
Your print is actually finding the media server.
Yeah.
Where it says you said.
So you actually sent the hello back yourself.
No, this is my client thread function, right? Oh, I understand what you're saying. This guy would be back on the server screen.
Right.
I get what you're saying. All right, so there's the you said, because this is all happening on the main thread. So this guy was the guy who connected, so he might be in Russia. It's the server that is spitting this stuff back out. So well, no, that actually shouldn't be. Oh, that print, but the broadcast should show up here.
Right.
Okay, and there's the broadcast. There's the hello. Okay, so it did work. All right, so then this guy can say LOL. There's the server, you said. So if we wanted to change this, we would, instead of saying you said to the server, we would do a send on our socket to us, you said, and then for everybody else. And we'll change that here in a second. So this guy sees the hello. This guy sees the LOL. This guy currently has seen, well, he typed in the LOL. So if I come here and I type in woot, we would expect this. Why isn't he seeing woot? Yeah, why isn't he seeing anything?
I had an issue with the socket that he was getting updated in the struct.
Yeah.
And so then when I was comparing against it, it was saying that it was whoever was the last person connected.
Okay, so just as a quick test then, let's just take out this if statement here and just broadcast to everybody. And but then you're saying then this would potentially not work right if we did our. No, that should still work.
Yeah.
So we'll go ahead and print to ourselves CT socket ID. The buffer, we probably would want to concatenate that with something else, but I don't really want to do the string cat right now, so let's just forget about that. Yeah, whatever. Let's make sure this goes to everyone now. All right, so there's it echoing to us and then coming to us again because we're part of everybody. All right, and then here is it getting to this guy. So this guy should be able to type LOL. That's it showing up to, actually this is showing up to us, but we're not actually being echoed. This. So you're saying the socket ID is not getting reset?
The socket ID is getting reset. It's getting reset, which whoever connected last is what everybody's socket ID is saying. So everybody has the same socket ID in their structure.
Okay, so that makes an argument that you should pass the pointer.
It works the same with whether.
Yeah. The pointer's not helping. It would mean that we need to do. We go back here to our chat server and go down here. It's this guy right here that's changing. I wonder if I move that int outside of here, so it's only created once. then fill it here. Then when we pass it, we're passing a copy of it. I don't know why that would actually make a difference, but it seems like it's not good programming practice to redefine that every single time through there. That should not make a difference in the value that's coming in here. Let's test that though, because I suspect it actually will make the difference. And then I'll figure out why it made the difference. Oh, probably need to have multiple connected clients in order to receive anything. All right, so that guy got the LOL. Then we'll say woot here. So we have our woot. Then, oh, this is us typing it. Oh, we did get a blank line here, though. Where's that coming from? That's strange. All right, so we expect this to broadcast once to us. That's going to be from this line right here. And then we expect it to also broadcast a second time to us. So we should see it 3 times. The time we typed it, pressed enter, broadcast to us once, press it, and then it kicks down, and then as part of the broadcast to everyone thing. So that's the broadcast to us. Well, that's us typing it. Here's the send just to us, and then here's us as part of that loop. And down here, we received just the hello. Well, that seems fine. I'll type in woot, so we should see woot 3 times here. Very interesting. We never received it here.
I don't think the server received it either on that last boot.
Well, the server wouldn't be receiving it because we're never printing it out at the server now. Okay, I think this might be our /0 stuff because what I did is press enter on a space here, and then things started flying through again. So it looks like we're reading in some things here that are partial reads. So at the end of a read, can I just set buffer up to be we need to 0 buffer back out. Can I just say buffer is equal to that? Is it going to be cool with that? Just setting it back to an old literal. Otherwise, we'll write buffer a different way. Yeah, it doesn't like that.
You just pass in the number of bytes read as the length of buffer?
That would actually make the most sense. Instead of the string length of buffer, we do have number of bytes read. So that in that particular case, we know exactly how much we recently read in, as opposed to let the string figure out where the termination of the string is. So that would have it write out that exact number of things. Then we wouldn't have to reset buffer because we wouldn't walk off the end of it. But this still doesn't fix the the presumed problem that we are off that we have the same socket ID multiple times. Let's just have these 2 guys individually connect. This guy send LOL, we should see it 3 times. We should see it once over here. When we say hello, we should see it 3 times. I see it twice. So this was the original send just to ourselves. But I see we kind of have this is like a waiting thing. Do we see the hello over here? We see it twice here. So is that the socket ID being duplicated? Should be able to fix it this way then. We get our socket ID. Let's go back down to main rather. We read in our new socket here. We've added it to our connected clients here. Let me increment number of connected clients after this. And let's set our thing. That way it's living in a different place in memory. So we'll set the socket ID to be the value that lives at number of connected clients. Bucket number of connected clients in connected clients, presuming that the problem is this new socket int variable as we're passing it to our struct. Hopefully putting it in a different memory location here preserves its long-term value. See if that made the difference. All right, we got 3 of them. We got 1. Still only got 2 of them. We got 2 of them there. So does that mean if I type in woot here, this was the second one that connected, which is now the official socket ID. I should see 3 here and still the 1 here. So this guy's working correctly, but the original one that connected, his new socket ID is now been overtaken with the new one that's come in. So in perpetuity, this guy only broadcasts. Oh, now he doesn't work at all? I said LOL. Why didn't that broadcast? Is this other guy still stuck? I think we saw that last time. If I pressed enter there. Let's print out the number of bytes read each time. Make sure that that read function is not continuing to block, because that's the way it looks like it's, that's what it looks like it's doing. So number of bytes read. Otherwise, we would see it broadcast back to us. So let's print out bytes read. And that's not how you do that in this language. This is %d and then \n. And there's our number of bytes read. So let's just prove that this guy is not blocking, that we are always reading in bytes after we press enter. Oh, printf. Okay. And this should be at the server. So we read 5 bytes. Then we'll type in woot. We read in 6 bytes, that broadcast. Then we'll say hello. That read 7 bytes. that did not read again. So when I just typed in hello here, we're still stuck. So now if I come in here and I just press enter, so this line is blocking after a point in time. Oh, is that because it can't read from that socket ID because it's changed? It's a dead socket. If I type in woot here, let's type in elephant. Now that read in 10 bytes. All right, so this guy is blocking permanently after the other one connects because his socket ID has now changed. Well, no, his socket ID has now been replaced by somebody else's socket ID. Let's print out those socket IDs. We really need to do it as a printf because we can't rely on being able to write to the socket if it's dead. So we'll say my socket ID %d \n, and this would be ct-socket ID. So each time through the loop on both clients, we'll have them broadcast what they think their socket ID is. And you're saying they'll be the same?
After the second client connects.
Yeah. All right, so this guy should be able to say LOL here. I saved this, right? I'm not getting the socket ID printed out. Did I actually compile? Thought I compiled. We said connected. So that's where we sent connected there. And then the very first thing I should be doing is printing out my socket ID. Why isn't that line hitting?
Did you save it? Because it's sitting on mine.
Yeah, I mean, I thought I hadn't saved the previous time. Isn't it, hold on. Command S. I thought, because usually on Windows you do Control S, and I thought that this website made it work as Control S, not Command S. All right. So that should show us printed out connected. Oh, hold on, did I did chat server. That guy's connected. As soon as it outputs connected here, then it should get into this loop and it should say my socket ID.
Try saving it again because you might have been installing it.
Oh, you're saying I was in this
Yeah.
window. I understand. Yeah. User error. All right, he got a socket ID of 4. Now this guy, you're saying he's also gonna have a socket ID. Okay.
Socket ID 5. Now, if you go to the original guy, you print something else.
Then it's gonna broadcast his socket ID again, and he's gonna say he's a 4.
I'm gonna say a 5.
Oh, because he's updated for the
Because
new
he
one.
updated to the new one. Yeah.
Why is that?
I think didn't we have that problem? I think we had something like that, and we switched it down in main when you're creating the struct.
Yeah.
We sent it as or we created it as a struct pointer, or as a struct client thread T pointer.
Where? When you're sending it in for your
line
thread?
120 or whatever, line 115, somewhere in there.
Right there.
Yeah, 111. We created that as a pointer, and then I also had to use malloc to allocate memory for that.
Oh.
So maybe they're all pointing to the same address.
Hold on, let's see. Socket connected. Where's my accept? Yeah, this should actually, I think, get fixed if we do this. Actually, this makes a whole lot of sense. So we're creating this client thread, which just exists once, right? And we're passing a pointer to the same client thread to every single one of our children. It's like, no wonder the numbers are the same. We're passing it the same struct, the identical struct every single time. So now you created a struct pointer client thread CT.
Client thread pointer, yeah. Because the star has to go after client thread T, right?
Right, because this is saying it's a struct, it's going to be a client thread pointer, it's going to be this guy, which is going to give us a place to put a new struct. Then you have to say CT this, right?
Mm-hmm. And then I had to use malloc
To allocate size of that struct. Yeah.
I
Okay.
think
That is what it is. I mean, it's working exactly as we've written it right now.
Yeah.
We've created a single struct, and we're passing an address to that struct to every single one of our threads. The same address. Because we only ever created one struct. So we need to create a struct each time through. So we need to allocate memory for that struct. So we're going to get a pointer to the struct. This guy's going to be malloc. And it's only 1 times, right? So you could just say size of. I think we have to say it like that. So we're saying we want enough memory to hold this much stuff. We're going to store that pointer to that memory here. Fill it up with our stuff here. Then when we pass it in, we'll pass in just CT, not the address of CT. Now we're creating unique memory for each of our structs. Instead of having one struct that we keep just changing little aspects of it. Now what's actually interesting here is that the reason the rest of it worked is we could have gotten away with just one struct for the rest of it. Because the rest of it was pointers to other things, right? And those are things that are only ever changed by one guy. So all of the child threads are all looking at that same central location. So now, same logic we had before should work. So now I should be able to go through and take out my socket ID, take out bytes read. This will still broadcast to everyone. So we see 3, we see 1 here, we say hello, we see 3, we see 1 here, woot, we see 3, we see 1 here. Because now we're actually broadcasting to unique people. All right, then the last piece we would have put in here is wrap this guy in if current socket ID is equal to the value of, actually it's just, we don't need to do the value, CT dot socket ID if it's not equal to me. Then broadcast it to the person that we're looking at. So find out who we're trying to broadcast it to. As long as it's not me, go ahead and broadcast it. So now we should only get it twice on our connections instead of 3 times. Oh. So there's the twice, there's the LOL, there's the hello twice, there's the hello. This is a test. There's the this is a test. So the fix for that thing is that for those of you who are having the sentence issue is pass in number of bytes read rather than string length. This number of bytes read then doesn't run into the problem of the \0. This is how much you just gave me. This is how much I'm going to write. Okay. All right. So no homework for next class. Remember, make sure you resubmit the stuff for Bible homework. We'll come back and look at this and see where our weakness is from a semaphore perspective. And I want to introduce semaphores on Friday.